Past, we have learned how to calculate and graph something linear, like the slope of, let's just say, the slide through y through y equals x, and that graph sort of looks like that. And we've also calculated how to find the trajectory of a ball, someone kicking a ball, through a quadratic function, or y equals x squared, which sort of looks like this. Now, but what happens when, let's say, you want to find and graph a roller coaster, something with multiple turns like that, or multiple parabolas? Well, that's a polynomial. That's the graph of a polynomial, and they could be a bit tricky to learn how to graph, and I'm here to show you that. First, in order to understand how to graph a polynomial, you need to understand end behavior. So, I have these four equations: y equals x squared, y equals x cubed, and y equals x to the fourth. And let's take a look at their graphs. So y equals x, that's a standard straight line. And look at the end behavior. You see that this sort of goes down, up. It's sort of like a slope. It goes up. Now y equals x squared, that is a parabola. You see how the arrows both point up. Now y equals x cubed, however, is similar to y equals x, where it sort of goes down and then up. And y equals x to the fourth is similar to y equals x squared, with both of them going up, both of the arrows leading up. To fully understand end behaviors, let's take a look at this example. Y equals x squared, which we know is a quadratic, like this, where it goes up, up. Well, let's take a look at the equation y equals x squared. It is to the second degree, and in end behavior, the degree matters a lot on whether it's even or odd. And because 2 is even, the degree we will say is even. The leading coefficient, though, is y equals x squared, which means it is positive. So, informally, you see the arrows, they point up, up. That is the informal end behavior. However, how do we say it formally? Well, we say it like this. As x goes to infinity, or as to the right of the y-axis, so as x gets larger, where does y go? In this case, it's up, up, so y goes to infinity, because it points up, so when x gets larger, y gets larger too. Same with the other side, as x goes to negative infinity, so x goes to the negative numbers and gets smaller. Where does y go? Well, y also goes up, which means infinity. So the formal way of saying it is, as x goes to infinity, f of x goes to infinity, and as x goes to negative infinity, f of x goes to infinity too. However, if you have an opposite, if you have y equals negative x squared, it's a bit different. Negative x squared. Well, because a negative in front means that it's reflected over the x-axis, which means it would sort of look like this, which is the opposite. So the leading coefficient is negative. And the informal way of saying that is down, down. So it's the opposite. As x goes to infinity, f of x, or y, goes to negative infinity. Same with this. However, when we have an odd degree, it becomes a bit different. So y equals x, that's an odd degree since the degree is 1, and 1 is odd. And this is a positive coefficient, and we know that this graph goes like this. So, since we read graphs left to right, it will be read as down, up, since it goes down to the left and up to the right. So, as x goes to infinity, as x gets larger, f of x, or y, gets larger too. However, as x goes to negative infinity, f of x gets smaller and goes down, so it becomes negative infinity. And it's a bit different. It's like the opposite if we switch up, if it's a different leading coefficient. If we have negative x, then it would become this, which means it's sort of up-down, because to the left it's going up and to the right it's going down. It will read graphs left to right. And it's the opposite. As x goes to infinity, f of x goes to negative infinity, so it's to the right and it's going down. But as x goes to negative infinity, f of x goes to infinity. By using end behaviors, we can actually somewhat start the graph of a polynomial. We can also find the equation of a graph of a polynomial through factored form and x-intercepts. See here, we know that it's down, up, which means it must be an odd degree and a positive leading coefficient. we know the y-intercept is equal to 0, negative 6, and the x-intercepts are negative 3, 0, negative 2, 0, and 1, 0. Now, similar to factored form in quadratics, we do this with y equals a, which is like the vertical stretch factor, x plus 3, and is the opposite. Oh, my bad. X plus 3, x plus 2, x minus 1. And we can actually find this a value by plugging in the y-intercept or another point on the polynomial. So we do negative 6 equals a, 3, because x is equal to 0, to negative 1. So we end up getting negative 6 equals negative 6a. And if you divide by negative 6 on both sides, a equals 1. And so the final equation is f of x equals x plus 3, x plus 2, x minus 1. And you just found the equation of a polynomial through x-intercepts. Now, what if the factors are to a different degree? Well, that's where something called multiplicity comes in. And so, for example, let's just see multiplicity 1. Now, that's the standard. You don't even have to write the 1, like we don't write the 1 in front of x. So, it's just 1. So, multiplicity 1. Now, what happens? When we're talking about multiplicity, we're talking about what happens at the x-intercept. Well, as we know before, at 1, it goes straight through, as seen before in other examples. So, it goes straight. However, multiplicity 2 changes. It actually bounces. It sort of hits the vertex of the parabola. And so multiplicity 3, it's similar to a cubic function, where it squiggles at the x-intercept. Okay, let's graph this polynomial. Let's graph this polynomial with keeping multiplicity in mind. Well, what's the degree? If we add up all the degrees of the factors, 3 plus 2 plus 1, you get 6, which means the degree is even. And there's no negative sign in front, which means the leading coefficient is odd. Or leading coefficient is positive, which means that it is up, up. So knowing that, let's mark our factors. X minus 1, that is 1. X plus 2, that's negative 2. X plus 1, that's negative 1. And we know that it is up, up. So up, up. Now, let's start left to right. At negative 2, what does it do? It's multiplicity 3, so it squiggles. So it goes like that. Now at x plus 1 or negative 1, it's supposed to bounce. So it goes like this. It goes somewhere around here. It goes up and turns, and it bounces. And we know x minus 1 or 1 goes straight through. So there. And you just graphed your first polynomial. Another way you could graph a polynomial is to increase and decrease. Now, what exactly is increase and decrease? Different ways. But how exactly will you use polynomials in the real life? Well, frankly, it all depends on your profession. Well, if you just happen to be working on a roller coaster, you'll be able to use polynomials to graph the roller coaster, to plan it out. And for roads, if you want to build roads, if you like to build roads or a bridge, you would have to use polynomials for that. Frankly, some jobs don't need polynomials. It all really depends on your profession, but just good to know in your mind. It's just good to know how exactly you can graph a polynomial.